Let's continue to rank metals from the most reactive to the least reactive metals. For this, in this video, we are going to react metals with dilute acid. And depending on how vigorously they react, we will rank them in this particular series. In general, when metals react with dilute acid, we get hydrogen gas, and with this, metal salt is being formed. For example, if I take zinc metal and react it with dilute HCl, so over here, zinc will displace the hydrogen. So we will get hydrogen gas, and it will form zinc chloride plus ZnCl2. Let me just balance this equation here. Yes. Along with this, we will also have some heat being generated. This is an exothermic reaction. Now let me show you an experiment of the same thing. Here, I have got dilute HCl in the test tube, and I'm going to add zinc metal to it. You can notice that the moment I add zinc, there are some bubbles evolving. Now that's happening because hydrogen is trying to escape out of the solution, and that's why it is forming bubbles. And also with this, there is heat being generated. I can notice that the test tube is getting warmer because of the heat. So when a metal reacts with dilute acid, we see the bubbling of hydrogen gas and the warming of the test tube. Now based on these two observations, I can tell whether a metal is more reactive or less reactive. See, if we observe that more amount of hydrogen gas is bubbling out or more heat is being generated, then definitely the metal reacting is going to be more reactive. Whereas if the amount of hydrogen gas coming out is less and the heat being generated is also less, in that case, the metal is less reactive. So let's carry out this experiment with different metals. This time, we are going to react magnesium with dilute HCl. So the products are going to be almost the same in this case also. Magnesium will displace hydrogen to give off hydrogen gas and will form magnesium chloride, which is the metal salt. And along with this, a lot of heat will be given off. So the products will be this. So let's look at this reaction in an actual experiment. So here I'm going to add magnesium strips to dilute HCl solution. So here you can notice the amount of bubbling this time is much more than what we saw in the case of zinc. See, you can compare. And I can also tell you the heat being generated is much more. I can feel the test tube is much warmer in the case of magnesium than in zinc. So based on these observations, we can say that magnesium is more reactive than zinc. Let's write it down. So magnesium is more reactive than zinc. Now we can carry out similar experiments for different metals like aluminium, iron, and copper and rank all of them in a particular series. So if you do that, you will notice that the maximum bubbling happens in case of magnesium, then in case of aluminium, then comes zinc, and then comes iron. The least bubbling happens in case of iron. And if you do the same experiment with copper, you would not even notice any bubbling at all. Copper does not even react with the dilute HCl. So we can put copper towards the end. Now, with this new information, let's update our old ranking of metals. You would recall that in previous videos we were reacting metals with water and oxygen. And depending on how vigorously each reacted, we ranked them something like this. But see, there was a problem with this ranking list. It wasn't very detailed. Like over here, you can see that aluminium, iron, and zinc, they all are clubbed together at one rank. Whereas over here, copper and lead, they are also clubbed together at one rank. We don't know for sure which one is more reactive between them. So let's update this with our new information, which is aluminium is more reactive than zinc, then more reactive than iron. So if we do that, this is what we will get. Yes. Now this list looks much detailed, but still there are some problems like copper and lead, which is more reactive. And for this, we will have to carry out more reactions, which we will do in later videos. But this will suffice for now. Before we close this video, let me give you some details. First being that do not react sodium and potassium with acid. See, these metals are very reactive. They even react with cold water, right? So if you react them with acid, the reaction could be very violent, very explosive even. That's why do not do this. Now, second being that, I told you when metals reacted with acid, they give off hydrogen gas. But that's not true for nitric acid. When metals react with nitric acid, we do not get hydrogen gas. And that's because nitric acid is a very good oxidizing agent. It can add oxygen very easily. So here in this case, nitric acid oxidizes the hydrogen being produced, adds oxygen to it, and finally we get water instead of hydrogen. Only magnesium and manganese are the two metals that can react with a very dilute form of HNO3 to give hydrogen gas. Now let's summarize the video. In this video we saw when metals react with dilute acid, what gas gets released. And based on this, we experimented with few metals and we arranged them in the order of their reactivity. I hope you are able to recall these blanks, and if not, then go back and watch the video again.